in this next lab, we're going to start actually adding some control to the furnace that we've been working with. And the first thing we're going to do is we're going to add a very simple thermostat. And that very simple thermostat is only going to control the heater. We'll keep the cooling manually operated, so you'll have a switch on an HMI that you can turn the cooling on and off. You'll also have a manual heater control. However, the idea behind this is now to automatically control the heat based on a set point. So I want to show you where we're going to be headed. So I want to draw this graph, and it's not a difficult graph, where this axis is going to be time, and this axis is going to be the process variable, and let's say that this is going to be 200 degrees, and this down here is going to be ambient or room ambient. So room ambient. And we're going to add a set point this time. And let me add the set point. And let's say our set point is 150 degrees. So the idea is that we're going to turn the heater on, or start the process up, and we're going to turn the heater on. And as soon as we start the process, if the heater is not on and the process is less than our set point, so this becomes our set point. This is where I want the furnace to control. So if our furnace is less than the set point, the heater should turn on and the heat should start to rise. And the heat's going to keep rising. When it reaches the set point, the heater will turn off. So the set point will be equal to the actual process variable that I chose. The heater will turn off. Now the heater itself is not going to immediately start to cool down. So what's going to happen is that the heat will still be building. The heater's not on here. It'll still be building, and then it'll gradually cool down, and it'll get back to set point. At the set point, or just slightly below the set point, the heater will turn on again. Well, at the heater turns on again, the heater doesn't generate heat immediately, so it'll cool, and then it'll gradually heat back up again, get the set point, the heater turns off, there's momentum, it keeps climbing, it comes back, and what you're going to get is this oscillation around the set point. And that's with simple thermostat control, turning on and off the heater. This type of control years ago used to be called bang bang. Sounds funny, doesn't it? It was called bang bang because the contactors, or the relays that were controlling the heater or heaters or whatever the device was that it was being turned on and off, used to literally bang, bang. You hear them turning on and off. So here you would have the heater turn off. Here you would have the heater turn on. Here you would have it turn off. Here you would have it turn on, and so on and so forth. And it gives you some simple control. But you will always have this oscillation around the set point. Now this point right in here, this particular point from here to here, this is called overshoot. So this is called overshoot. We're also going to learn later on that we're going to call this error, because this is error. When I'm not at set point, I have error in the system. This point from here to here is called undershoot. It is also called error. Our idea is that we really want to get rid of this oscillation. We want to get rid of the error in our process. We want our process to control nicely. So like I said, in the lab that you're about to do, which is the furnace with a simple thermostat for heat only, the process will ramp up and the heater will turn on and off, and the temperature is going to oscillate around the set point. What we are actually going to try to achieve in our lab work toward the end, now to the end of the semester, is an ideal control system whereby the control will ramp up, and as it gets approaching the set point, it'll get on set point, and I'm not showing it on set point, but it'll get on set point and stay on set point. That's the desired effect that we want to see. So again, in this lab, we're doing a simple thermostat with a heater only on and off and manual cooling. So there's nothing to submit for this lab. You're just going to be turning in, or you're just going to be recording some data of how much overshoot, how much undershoot, how much time it takes for this stuff to happen. And then in the next lab, we'll start adding some more control to it. So have fun with this, and by the time the end of the semester comes, we're going to have a furnace that will hopefully control to set point wherever you set the temperature to be. And I'll see you next time.